So in this problem, we have to figure out the maximum force F where M1 does not slide off of the top of M2, that they sort of move together. And so we have to acknowledge that both blocks actually have an acceleration in the x direction. So the net force of x is equal to ma, and the net force of y is equal to 0 since the blocks don't accelerate up or down. We have to, as usual, take a free body diagram of each block. We have a normal force, we have force F, we have a friction force, and of course this is static. We have mass times gravity, or gravity force. All of these acting on M1, and M2 is very similar. We have mg. We also have N, let's call this N1. N1, and there's N2. So this N1, well, mass 1 is being pushed up by mass 2. And so we have to take that into account, that it has an equal and opposite reaction. And 1 has to also have an opposite reaction on the mass 2. And so then we see that sort of pointing down. In the same way, M2 also has a static force that pushes it to the right. Because this static friction is a force exerted by M2, and so M2 sort of has to counteract it, right? Every force has an equal and opposite reaction. Every normal force has an opposite. And a lot of the time, it's just the ground. And so we don't look at the ground. We don't need to. But for this problem, when we have two blocks, we do end up looking at sort of some of the reaction forces. And so both of these net force expressions apply to both blocks. The net force in the y direction is 0 for both, and it's the mass 1 or mass 2 respectively times acceleration for the other blocks. So the other thing to acknowledge is acceleration is constant, right? We have to accelerate the blocks together at the same rate, otherwise one of them is going to fall off, kind of thing, right? So we know we just have 1A. We're not going to say A1 and A2, we're just going to say A. So let's look at the net force in the x direction first. Net force in the x direction is equal to, oops, went a little too far there. We have this sort of theta there that pushes down. So we have the positive force is F, and we want the x component, so that's adjacent cosine theta. And in the negative direction, we have static friction, and that is equal to m1 times a. And if we look at the net force in the x direction for the other block, it is just the static friction, and that's equal to m2 times a. And that's a little bit simpler. Let's look at the y direction. For this, we have m1 minus mg minus the y component of force, which is just sine theta, and that is equal to 0. The same thing goes for the other block, n2 minus n1 minus m2g. Let's go back and label that as m1. We have m1 and m2 just to distinguish the two, and that's equal to 0. Good, we're getting somewhere. We're getting some equations. Let's see. Do we have enough equations to go ahead and start solving for variables? Well, one thing we know is the force of friction, Fs. We know that the force of static friction is mu sub s times n. So, well, let's look at our y expression. We have n1 is equal to m1g plus f sine theta. And we can plug that in there. This means n1. So we can say that our static friction is mu sub s times m1g. That's a sloppy m, but and then mu sub s f sine theta. Make sure mu sub s is distributed to both terms. And here we have an expression for static friction. We can use that just to kind of work out the kinks of our expressions. Now, the last thing we don't know is acceleration. So we're actually going to want to take this expression and say that A equals f sub s over m2, or that acceleration is, well, this whole nasty thing, mu m1g plus mu s f sine theta over m2. Sorry, not m squared, m2. And so we have an expression for a. We're going to go back to our first x expression and just start plugging in what we know. F cosine theta is fine. We don't plug anything in. Then we have minus the static friction. So minus mu sub s m1 g plus mu sub s f sine theta. And that is equal to m1 times a. So we have m1 over m2 times mu sub s m1g plus mu sub s f sine theta. And so this is a pretty nasty algebraic expression. What we have to do now is go through and turn it into f equals, which can be a little tricky. The first thing to do is to rearrange the right side. And we're going to just distribute that m1 and m2 to both terms. Let's see. Times mu sub s f sine theta. And after that, we're going to subtract this term from both sides. So we will add this term to both sides, just moving two terms around, and we're going to go ahead and rewrite this whole expression. And so moving those terms around a little bit, we get to here, and of course we factor out the f. Whenever you have, f equals is where you're trying to go, you're trying to get f equals, and f is buried in multiple terms, like we have f in 3 different terms. How do we get it out? Well, we bring all those terms to one side, and then we factor it out, right? So now it's just f times this big quantity, cosine theta plus mu s sine theta minus m1 over m2 mu sub s sine theta, right? So we're getting pretty close to a nicer expression. And there may be some algebraic sort of missteps in the solution to this problem. And if there are, don't worry, the final expression will be correct. So as long as you arrive at the same final answer, your work is correct. So we get f equals m1 over m2 times mu sub s m1g plus mu sub s m1g interesting, kind of two similar terms, just making sure we didn't make a mistake there. And we divide that by cosine theta plus mu sub s sine theta minus m1 over m2 mu sub s sine theta. Now this is a pretty nasty, pretty hairy expression. You can simplify this a little bit by, let's see, we can multiply every single term by m2. What I'm doing here is this is kind of a good final answer. Like, you'll be fine turning this in. It's just a little bit messy. It can be simplified a little bit. We will now just kind of work towards the answer that the answer key has, just so that way if you guys are looking at the answer key, you can see how they got that, as well as you can just double check that your answer key, that your answer to this problem is correct. If you go through all this, you'll know for sure, but it can be a little more tedious and feel a little unnecessary. We're going to multiply everything by m2. And so in the first term, it cancels out the m2. And we no longer have a division by m2. And in the second term, we just tack the m2 on the end. m2 cosine theta plus m2 u sub s sine theta minus m1 mu sub s sine theta. Let's see. This denominator can be simplified a little bit further. Most of what this is just weird algebraic simplifications that may or may not feel like they're really simpler. It's kind of tricky to see a lot of these, and most of them suck. But you can factor out m1, u sub s, and g from the top, and get m1 plus m2, right? And this looks a little better, just looks a little cleaner. And then down at the bottom, we have m2 cosine theta minus u sub s sine theta times m2 minus m1. Whoops, it should be plus, yeah, plus. That plus comes down. We just have that minus m1. And so this is pretty simple. The answer key takes this negative m2 minus m1. They kind of flip it and turn this positive into a negative. That's not what I would see as simpler. I see this as simpler, but the m1 plus m2 term would be better. But this is a very good final answer. If you can get this far, then you will be doing quite well on this problem. But this is the correct result. And if you get this, you know you did it right.